Hello students, welcome back to a chapter called Linear Programming Problem. In this module we are going to study steps to formulate LPP. So let's start with step 1 to formulate LPP. So step 1 says that identify the decision variables and assign symbols x, y or x1, x2 to them. So in this example, that is chocolate company example, we have seen that the manager needs to decide number of machine-made chocolates and handmade chocolates to produce. So basically these will be our decision variables. So let number of batches of machine-made chocolates be x and number of batches of handmade chocolates to be produced be y. So this is what we call as decision variables. Next step deals with calculating objective function, that is identify aim or objective which we need to maximize or minimize and denote it by some capital letter Z. Now consider that profit per batch for machine made chocolates is rupees 200. So one batch of machine made chocolates makes 200 rupees profit. So such X batches would make 200 into X rupees profit. Similarly, when profit per batch for handmade chocolates is given as rupees 400, then the profit for Y batches of handmade chocolates is calculated as 400 multiplied by Y. And what is the total profit of the company? Obviously, we need to add these two profits. So let's denote that profit by Z. So total profit Z is equal to 200x plus 400y, and this is what we call as objective. And since the objective is about profit, we are talking about profit, we have seen that we have to maximize profit and minimize cost. So we have to maximize here. So maximize z equal to 200x plus 400y is our objective function. Now we will move to the next step, that is step 3. So step 3 is basically deals with identifying all the constraints in given problem and express them as linear inequalities or inequations. So let that one machine made chocolate batch requires 4 hours of labor time. So obviously X machine made chocolate batches require 4 into X hours of labor time. Similarly, if one handmade chocolate batch requires 18 hours of labor time, then Y such handmade batches require 18 into Y hours of labor time. So how much is the total required labor time to calculate machine made as well as handmade chocolate batches? Total required labor time will be addition of these two, that is 4x plus 18y. Remember, total required labor time here is 4x plus 18y hours. Now suppose there are 20 employees who work for 40 hours per week, and total available labor time will be 20 multiplied by 40, that is 800 hours per week. So we have total available labor time as 800 hours per week. And now we have restriction that obviously total required labor time can never exceed total available labor time. So 4x plus 18y must always be less than or equal to 800, and this is our constraint 1. We will calculate one more constraint. Suppose that one machine made chocolate batch requires 12 hours of machine time, and therefore such X machine made chocolate batches require 12 into X hours of machine time. Similarly, if one handmade chocolate batch requires 6 hours of machine time, Y such handmade chocolate batches require 6 into Y hours of machine time. So total machine time needed would be obviously addition of these two, that is 12x plus 6y hours. And now suppose available machine time with company is only 1200 hours. So we know that total required machine time can never exceed total available machine time. So obviously 12x plus 6y must always be less than or equal to 1200. That is our constraint 2, and then we proceed for our last step, that is finding out non-negativity restrictions or finding out hidden conditions. So step 4, we know that number of machine-made chocolate, that is X, and number of handmade chocolates, Y, can never be less than 0. A company cannot produce negative number of chocolates. So obviously X is always greater or equal to 0 and Y is always greater or equal to 0, and that is what we call as non-negativity constraints. So combining all these steps, we will formulate now our LPP, that is maximize Z equal to 200x plus 400y. That was our objective function, and the constraints were 4x plus 18y less than or equal to 800, 12x plus 6y less than or equal to 1200, and lastly non-negativity constraints, that are x greater than or equal to 0 and y greater than or equal to 0. So this whole constitutes our LPP. So in this module we have studied how to formulate LPP. Thank you.